So we are graphing everything in addition to vertical shift. That's really the last one we're really going to be concerned with. Look what's going to happen tomorrow. We'll do a little bit of phase shift, just a little bit. We won't do a lot because seriously, if you know the shape of the curve and you know the period of the curve, the starting, the ending, the points in the middle, you're really good to go. Everything is based upon, I always worry about that. The graph is based, graphed around. What was the name of that line that I always highlighted? Do you remember the name of that line?
Oscillation line.
The oscillation line.
Sounds like oscillation.
Oscillation line. Okay?
What is,
Go ahead.
what is oscillation mean?
Well, you know, an oscillating fan like this means it goes around one axis. It has a central axis that it rotates about. Same thing with this. The curve is based around that line, one central axis. Kind of like an imaginary axis, I guess. I'm not for it. First person ever asked me. I use it for the foundation of everything. Because until I did that, I did not understand how to graph these. I didn't get it. First, oh Lord, it was awful. Graphing was horrible. Bless you. Remember about the general form of the equation. We are going to write this again. I know it's already in your notes. I don't care. I'm going to write it again. It is A sine bx plus c plus d. Okay? And just to review this stuff again, the A stands for what? Amplitude. Amplitude does what to the curve? Tall or short, okay? What's the B help us determine? The period. But it's not really that number, it's really what? It's always going to be what? 2 pi divided by the absolute value of B, isn't it? Okay? So we have to divide that number, that coefficient B, that coefficient of X, into 2 pi, and then we graph our X intervals. The C, the plus or minus C, which we're going to save until tomorrow, what's it based upon? That's your phase shift. Okay? What does phase shift do to the curve?
Left and right.
Moves it left and right. Okay? It has a left and right. Let's use a fancy word. Translation. Could be a left translation. It could be a right. A slide. A move. And then the one we're concerned about no pun intended, today is going to help us with finding the what? Vertical shift. Okay? This is exactly like our parabolas. We looked at that parabola problem yesterday. If you can understand what to do for that right there, the general form of a parabola, which way is that thing going to be moved? Up 1, okay? If it were a minus 1, it would be moved down 1, right? Same thing for this. If it's a plus number, then we're going to go, if it's plus D, then we move up. If it's minus D, we move down. Right on? Everybody cool? The vertical shift is where we put the oscillation line. Okay? That's probably the most important thing you have, is this determines where the oscillation line place. Now, where was our oscillation line all day yesterday? It was at y equals 0, where it was the x-axis, correct? And what did we not have in our equation? We never had a d term, right? So therefore, it was 0, correct? So what's going to happen, everybody got that? What's going to happen when we start graphing y equals, just go to something easy, sine x minus 3. Very easy. Hey, what do we have to do even if we don't want to? You got to do all the pre-work, and you start from the beginning. Is this thing going to reflect? No, there's no reflection. What's the sine curve look like? Sine curve looks like a snake, and it's going to go down first, up first. Up, down, up. And that's just my middle note. Actually, it's a middle note on paper. Reflect. Next piece. What's the next piece? Amplitude. What's the amplitude of this one? 1. There's nothing in front of sine. It is that understood 1, though. There really is that 1 there. So it's the absolute value of 1, which is 1. It's going to move up 1 and down 1 from the oscillation line. The next piece is the period. Where do we get the period? In front of the x. It is 1, so it's 2 pi divided by 1, which is 2 pi. What does the period determine in the curve? The length, the horizontal length of the curve. How long, how wide is this thing going to go? Okay? Now, PS, what's that stand for? Phase shift. Is there any phase shift in this? How do you know? There's no parentheses. That is as easy as it gets for an explanation. There are no parentheses. Vertical shift? Yes. It's going to move down 3. Okay? Down 3. So here we go. You ready for this? All right. So if it's going to move down 3, look how I made my axis real heavy on the bottom. Because if it has to move down 3, then it's got to be here, doesn't it? Immediately draw your oscillation line. If I were sitting at a desk with my pouch full of colored pencils and markers and such, I would take out a highlighter or something. I'm going to use a crayon today. Actually, I'm going to use a red crayon. Because, why not? Okay? And I'm going to draw my oscillation line as soon as I make my vertical shift. Amen? You're supposed to amen too, y'all.
Oh, sorry.
Or at least you're supposed to go, mm-hmm. Y'all didn't even do it. Pitiful, pitiful children. Y'all just look at me like I'm crazy. I don't mind. Philip, I don't mind. I'm used to it by now.
Do you have to draw that first one?
This one? What is that? That's my y-axis. So yeah, I have to draw my y-axis. Mm-hmm. And I'm going to draw my y-axis. Okay? Now, why did I put a line under the oscillation line?
Because you have to go down one and up.
Because I have to go down 1 and up 1. Where does the sine curve start? It typically starts at 0, right? But it always starts and ends for the sine curve on the what? On the oscillation line. So I'm going to have, check this out. Make sure your intervals are kind of even, y'all. You know I can be kind of nitpicky about things, right? Like, watch this. This is what I want you to do. I'm going to go up here. I have to go up 1 unit, and then back down, and then back up. It better hit about 1 unit below the oscillation line, because the amplitude is based, it's the height above the oscillation line and the height, if you will, below the oscillation line. That's better, right there. Now, where am I going to put my x intervals? I'll tell you where I'm not going to put them. I ain't going to put them on the oscillation line because my intervals don't go on the oscillation line. Where do they go? On the x-axis. Come on now. It's going to go to where? It's 0 to 2 pi. This middle point, that moment in time when that curve, it's just come down the hill and it's getting ready to make that turn up the hill. This point in time in the middle of the curve is what? It's pi. And then, of course, halfway, the maximum value occurs when x is what? Pi over 2. And the minimum part of the curve occurs where? When x is 3 pi over 2. What do you think about that? Is that so bad? I'm going to tell you, I struggled one entire school year with this. And then it clicked. And I went, oh, draw the stupid oscillation line. Everything's based upon it. And it's so easy. It's so easy. Can we do another one? All right, you're going to do another one. It's going to be another sine curve.
We're gonna do like tangent curves and stuff like that.
Yes, but we do it a different way. You know what? I mean, we'll stay in the land of twos. Why not? Since everything says two. I triple dog dare you to get this right. Here it's unsmushed, and here it's smushed, okay? Here's another way it could be written, just for kicks and giggles. Do not be thrown if the vertical shift is at the front. What property says I can move that thing around? The commutative property says I can change the order and it's still legit. It's still okay. All right, just be prepared. You know that's coming, right? You know I'm going to get ready to change things around, right? So what's the next curve we have to graph? We got to go to the cosine. Here's another one. Ready? Everybody ready? If you're ready, go. Are we ready? I said, are we ready? Oh yeah. Oh yeah. Hey, he's from Minnesota. Here we go. Next one is cosine. I feel like it's a concert, like I'm getting ready to perform. The next song I'll be singing is a little song called Cosine. That's so stupid. I don't know why this thing's going in my head, y'all. Cosine. Ooh, this is going to be
Don't worry, we got it cleaned up.
Why'd you do that?
Because
I don't like that.
I don't care. I don't care. What is wrong with that? It's looking at me weird. Stop it. Let's make it look right. How would I make it look right?
Cosine of x plus 3.
2 cosine x. Just change it around. See, that's the easy.
Minus 3.
Nope. Why is it plus 3? Because it's on the same side. If it's on the same side, it keeps the sign. If I'd have moved it over here with the y, then I'd change the sign. But it's a positive 3, and I'm just putting it at the end of the equation, the expression. Okay? Now, does this thing reflect? No. What's it going to look like? Up cup, down cup. Up cup is happy. Remember the dotted line, the oscillation line's in the middle. I'm telling you, if you keep drawing it and keep writing that little sketch, that will help you. What's the amplitude? That's right, 2. What's the period? 2 pi divided by who? Which is 2 pi, right on? Phase shift. Is there any phase shift? Nope. And vertical shift? Up 3. So this is going to be heavy at the top or bottom of my axis? At the top, okay? Because 1, 2, 3, 4, 5, 6. My oscillation line's going where?
3.
It's going at 3. 1, 2, 3. Right there. Should have been using a crayon a long time ago. That's just a fun one. Isn't it, Grant?
It looks kind of like the favorite crayon.
It does. It does. Now, Where does cosine curve start?
At 5.
What? What?
Because
Why does it start at 5?
you gotta go up to
From the
the oscillation.
oscillation line. Very good. And it's an up cut. So where's it? So that means it's going to start at 5 and end at 5, won't it, Morgan? Where's the minimum value going to be? Yep. Daggone shooting right. Because we're going 2 above and 2 below. Okay, that's the amplitude. 2 above, 2 below. The oscillation line. Isn't that cool? I'm impressed.
Yay.
Okay. Up cut. Smooth and beautiful. That's not so smooth and
It's a
beautiful.
little V.
That's not a V. Better not be a V. It better have smooth and beautiful curves. Where does it start? That's right, 0. It's going to 2 pi. What's the minimum value's x value? Pi. The quarter point is pi over 2. And the 3/4 point is 3 pi over 2, folks. You should always be focused on this while you're in this class, okay? Was that so bad? That wasn't so bad. What's your key? The anchor to all of this, the oscillation line. Once you figure that out, this is a piece of cake. Now, Carol's mistakes can be made because you want to know where I wanted to take that cup. I wanted to take it all the way down here to the x-axis. And then when Morgan said 1, I went, oh, dang, she's right. That's just Carol's mistake that I would have made, okay? Can we do another one? Okay, you're on your own on this one. 4, 5. Should do this one on your own. Or you can pair up, squat up, if you want to. I don't care. -3 cosine x over 2 minus 1. You may have to rewrite it to make it look the way you want it to. You got 2 minutes. What do we have here? What do we have for reflection? Tori, what you have for reflection? Yeah? What's it gonna do? What's this gonna look like? A down cut? Yep, down cut. I agree. Oscillation line in the middle. If you keep drawing it, it will keep helping. Amplitude. Taylor, what'd you get for amplitude? 3. It's the absolute value of -3, which is +3. Period. Tatiana, what'd you get for that?
4 pi.
2 pi divided by what? 1/2. Y'all know I have to do it this way. Divided by 2 pi times 2. Aha. 4 pi. I'll eventually get it. I won't get it as quickly as you, but I'll get it. How many of y'all got the 4 pi for the period? That makes it easy, right? Makes it really easy. Phase shift. Is there any phase shift on the D? No. Vertical shift. Tamara. There's one where? Down 1. Okay. So, my oscillation line goes where? At -1. Where does it go? Tell me again. -1, -1, -1. Okay. Where do I start? This is cosine curve. So I have to go 3 above, 3 below, right? And it's what kind of cup? It's a down cup. So I have, right? It's a down cup, so I have to start 1, 2, 3, and -4? Let me make that in red. And it's gonna go somewhere right there? Because that's when I plot my beginning and my end. What's the next thing I usually plot? My middle, which is gonna be where? Smooth and beautiful. Gotta make it smooth and beautiful. It better not be a V, because if it is, I'm gonna say wrong function. This is not, what kind of function is a V? Will that do? That'll do. How about those intervals? Who we got? Jada, what'd you get? 0 to what?
But,
What's the end of the period though? 4 pi. Sarah, what's the middle point? What's half of 4? 2 pi. Samantha, what's the other? The quarter point is pi. And then Madison, what's the third? 3 pi. How many of you have that? Do you have every piece of that correct? Is that because it was before or after? Were you doing the problem? How many of you had it on your paper before I got it done? How many of you completed it with me? And it's okay if you did. It's totally fine. What do you think?
are you supposed to, like, are you supposed to, like, put the pi and the 3 pi where the crosses x-axis?
It's got to be in. No, it's not going to be where it crosses the x-axis.
That's where it crosses the oscillation.
Yes. That's a good. Atta girl. But be sure you label your x-axis. Okay. Do you guys understand what she just asked? My pi won't be here where the curve crosses the x-axis. It's going to be halfway between 0 and 2 pi. Because I always want to keep my intervals equal, right? Easy? How many of you say bring it on? Bring it on. How many of you say, psych? How many of you say, please help me? I don't know. It's okay. It's all right if you do. So I'll be here today until like 5-ish. If you ever have questions on homework, you want to get caught up on stuff, today I'm here till 5. Tomorrow I'm here until 5. All is well. The Andes, Port faces. I want you to get this before you leave.
That's in the book.
Nope. The book's horrible. It's calligraphy. It's okay to read.
Like,
Omar, are you being critical again? Why do you want to be so rude?
That sounded so weird.
I did. Yes, I did. Yes, I did.
I'm doing this and then.
Do this right now before you leave. That's why I'm giving you some time in class.
4 minutes.
4 minutes, 4 minutes.
Yes, 4 minutes.
Hey, I'm on Casey, I think. I just want to see 4 minutes.